Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live we will be going through, as you can see, the Edexcel November 2019 paper 3 for higher tier. Obviously, I realise you have English tomorrow, so if you're studying for that you can watch this just later on. It will be in the lives playlist on my channel, so you can come back and have a look tomorrow or another day if you want. I'm just going to get straight into it, and if you have any questions then obviously leave them in the chat below. So question 1, expand and simplify x plus 5 multiplied by x minus 9. Obviously the brackets mean multiply, so we're just going to expand it. We've got x times, if I get my pen right, we've got x times x, which is x squared. We've then got x times 9, so minus 9x. We've then got 5 times x, so plus 5x. And finally 5 times minus 9, which is minus 45. Obviously that's the expand bit, isn't it? They've then said simplify, so that just means the two terms in the middle, because they're both x terms, we can add those together. So you should get x squared minus 4x minus 45 overall for your answer. Part B is then to factorise fully 9x squared plus 6x. Now obviously it is a quadratic in terms of it's got an x squared, but because it's missing the final term, if you look at this quadratic, it's got 3 terms, hasn't it? Because it's missing just the number at the end, that means that you can only factorise it into a single bracket. So what I'm going to look for is what can I kind of pull out as a common factor. Obviously in terms of numbers, the highest common factor is 3, but then also in terms of letters, I've got an x in each part, haven't I? So I can pull out 3x, then I just have to fill out what's in the middle. Yeah, exactly. So obviously from 3x to get to 9x squared, we're missing another 3x. From 3x to get back to 6x, we're just missing a 2. So yeah, you're right, 3x and then 3x plus 2 in the brackets, exactly. Okay, question 2 is quite a nice one. It's just a calculator use one, basically. So use your calculator to work out 29 squared minus 4.6 divided by the square root of 35 minus 1.9 cubed. It's just testing to see if you know how to use your calculator, basically. Write down all the figures on your calculator display, so don't round it for part A. So actually, let me get my fraction there. 29 squared minus 4.6, and then we've got a square root 35 minus 1.9, but that's cubed. So I get 157.668255. So I'm going to write literally all of those decimals down. So 157, where's my pen gone? 157.668255. So that's part A, 2 marks for that, which is really nice. Write your answer to part A correct to 4 significant figures. So let's count. We've got 1, 2, 3, 4. But then we check the next one to see if it's above or below 5. Because the next one is higher than 5, it's bigger than 5, I'm going to round this one up. So it'll be 157.7. Yes, exactly, 157.7. Yep, triple brackets in paper 2. That's really good. That's a nice question, isn't it? Question 3 is scatter graph. So the scatter graph shows information about the marks a group of students got in a science test and in a maths test. So you can see science is on the x-axis and maths is on the y-axis. Jamie got a mark of 34 in the science test. Using the scatter graph, find an estimate for Jamie's mark in the maths test. Yeah, so what I would do is I would literally just draw a line of best fit and then kind of go up at 34. So let's get a straight line, just as best you can. There are obviously a different range of answers for this one because everyone's left, line of best fit is going to look slightly different. I just try to get as many of the crosses kind of above the line as below, just roughly. So I think mine was maybe something like that, more or less. Obviously yours might look slightly different. That's okay, as long as you get the answer within the range, which I'll tell you in a minute. So obviously then I'm looking at the science test is 34. So coming to the science axis, go up at 34. Do check the scale of the axis is, what you think it is. So here I've got, and obviously across, that's given me 39. So I got 39. When I did it on a piece of paper, because I printed it out, I got 40. They've said anything between 35 to 42. So quite a big range, because obviously, as I said, your line of best fit isn't going to be identical to anyone else's. So as long as you've got something between 35 and 42, then that's fine. Just check in the comments. Yeah, you got 39 too. Perfect. That's fine. As I said, anything between this range is absolutely fine. And you've obviously just leave your line of best fit there. Don't rub it out. Just leave it so they can see that that's what you did. Question 4, another pretty nice one, this one. If you've got the method memorized, then it's a pretty straightforward question. So the table gives information about the times taken in seconds by 18 students to run a race. So you can see we've got some ranges here. This would technically add up to 18 because they've said it in the question. Work out an estimate for the mean time. So this is mean from a frequency table, isn't it? So I like to create 2 more columns. So I do the midpoint because we have to, that's where the estimate comes in, isn't it? We don't know, for example, the 8 people that took between 20 and 25 seconds, we don't know actually exactly what those points were, somewhere between 20 and 25. So the midpoint is kind of our estimate, isn't it? So 7.5, 12.5. If you are not sure just by looking at it what the midpoint is, what you can do, and this works for any kind of midpoint, is add them together and then half it. That will tell you the midpoint. If you're not, sometimes you look at it and it's not as obvious. Some of them are a little bit more tricky. So you can use that method to find the midpoint for anything. Also midpoint for coordinates if they have that question. Same thing. So I've worked out my midpoints. Then my next column is going to be the frequency multiplied by the midpoint, because if you think about it, I've got 1 person at 7.5 seconds, 2 people at 12.5 seconds, 7 people at 17.5 seconds. You get the gist. So we're just multiplying all of these. So obviously that one's just 7.5. That one's 25. This one I got 122.5. And finally 180. Then we add this column, because that's all of our seconds, isn't it? Which gives you 335. And then finally, down here, to find the mean, it's when you add them all together and divide by how many there are. Well, we've added them all together. That was this bit here, wasn't it? And divide by how many there are. There are 18. Let me grab my calculator so we can see. Divided by 18. They said to 3 significant figures. Oh, don't want to zoom it. So that would be 18.6. Just checking the comments. The problem is I know that you've had a mean question, but it wasn't mean from a frequency table, so I don't know. I mean, would they ask mean generally twice? Maybe, I'm not sure. So this could come up, or maybe it won't because they've already asked a version of mean. I'm not really sure. Yep, you've got 18.6, that's fine. Yeah, if it comes up, it's just this method, isn't it? So that's nice. Nice 3 marks there. Okay, question 5. We've got a conversion. So write 37.3, why have I read it like that? 37 centimeters cubed into millimeters cubed. I can't even read the sentence for some reason. Yeah, there's a different way, I guess. You might have memorized it, but there's so many different conversions they could ask you that I feel like I wouldn't have memorized them all, because this is centimeters cubed, millimeters cubed. It could be centimeters cubed and meters cubed. It could be kilometers. It could be, squared, things like that. There's so many different conversions. So I didn't really memorize the conversion. I know it's only 1 mark, but I can show you how to work it out if you're not sure how to do it, if you don't have that conversion memorized. Because obviously it's cubed, it's not the same as, we know that 1 centimeter is 10 millimeters. I feel like that one we just know because you can look at your ruler and it shows you. But that's 1-dimensional, isn't it? This is 3-dimensional, so it's not just by 10. So the way that I think about it is, because it's cubed, just imagine it's a cube, literally. All the sides are the same. And this is a measurement of volume, isn't it? So you can imagine that's a cube. Okay, well, I know the conversion for 1 dimension, which is a side length, isn't it? Effectively, 1 dimension is a side length. So let me get this back to the side lengths. So what I would do is I would just, because it's a calculator paper as well, cube root it, because that would give you, from the volume back to just 1 side length, wouldn't it? Which I know is going to be decimals, but not square root. Lets me cube root. So what I'm saying is technically each side of this cube is 3.33 ... centimeters. Obviously keep the exact answer there in your calculator. Centimeters, this one's 3.33, this one here is 3.33. You get the gist. So imagine I had the exact same cube. You don't have to draw this on your actual paper, I'm just kind of explaining it. Imagine that was exactly the same cube. What would that be in millimeters? Well, because it's 10 millimeters per centimeter, that would mean it would be 33.3, obviously ... millimeters by 33.3 by 33.3. And then you go, well, how do I make it three-dimensional again? You take this answer and cube it, don't you? So this answer here, that's our centimeters. Multiply it by 10, that's how many millimeters are each side of my cube. Now, if I want the volume, I cube that and it gives me 37,000. So if you haven't memorized it, you can kind of think of it that way. Bring it back down to just one dimension, just a side length, and then convert it when you know that one-dimensional conversion, and then bring it back up to, in this case, volume. Now, obviously, therefore, the conversion in this case, if you want to memorize it, which is also fine, 1 centimeter cubed is 1,000 millimeters cubed. You can also just memorize that if you want, but I don't know if they're going to ask this one or, as I said, loads of different other ones. So yeah, let me just have a look at the comments. 10 times 10 to the power of 3. Yeah, scale factor cubed, I guess you could think of it that way. 37 times 10 to the power of 3. That would be the same, wouldn't it? Yeah. Yeah. You can do it different, as long as you get this answer. It's only 1 mark, isn't it? They're not looking for working out marks in this case. There's only 1 mark. So they're only looking for the correct answer. So you don't have to write any working out. If you just knew how to do it, that's absolutely fine. As long as you get the same answer, it doesn't matter. I was just doing it this way to just kind of try and, if you didn't memorize it or you didn't have another method, this is how I would explain how it works. Because obviously the one-dimensional conversions we should know for the majority of them, right? Millimeters, centimeters, meters, kilometers, all of that we should know in terms of one dimension, so in terms of a side length. So if you're in doubt, you can always bring it back to just thinking of it as a side length. That's just how I was thinking about it. But if you have got it memorized, or if you've got an easier way to do it, then that's also fine. So yeah, as long as you got 37,000, it doesn't matter how you got there. Just thought I'd kind of over-explain, you know, one option of how to figure it out if you didn't have it memorized already. So, question 6, Nimmer was driving to a hotel. He looked at his sat-nav at 1:30. 1:30. Distance to the destination is another 65 miles. Nimmer arrived at the hotel at 2:48. Work out the average speed of the car from 1:30 to 2:48. So obviously we know speed is distance over time. So we've got the distance, that's pretty straightforward, isn't it? 65 miles. It's mostly the time that we're actually having to work out. So the time, we obviously have to work out literally in terms of a clock. So I was thinking, oh yeah, it's like an hour to 2:30 and then another 18 minutes. So it's 1 hour, 18 minutes. But because if you see the answer here, I don't know if you can just about see that, they want obviously the speed in terms of miles per hour, not miles per hour and minutes. So before I start dividing, I'm going to have to convert this into just hours. So there's a few different ways. What I did was I said, well, I know that there are 60 minutes in 1 hour. Then there's the extra 18 minutes, isn't it? So it's 78 minutes. And then if I divide that by 60, it gives me a decimal for hours. So it's obviously 1 hour, 0.3. 1.3 hours. So I can do 65 divided by 1.3. 65 divided by 1.3. And that gives me 50 exactly. Yep. 50 miles per hour. A nice 4 mark, you can't even see that, but that's 4 marks actually, which I thought was quite generous, to be honest. That's quite a nice one. Yeah, I don't think you've had speed, distance, time yet, and I feel like it comes up so much, so I in my head I feel like it might come up in paper 3. Some version of that, whether it's question 6 or whether it's at the end of the paper, I don't know. But I feel like they're going to ask it at some point. So, question 7, write 32,460,000 in standard form. I know you've already had standard form, I think, in paper 1, so whether it will come up again, I don't know. Yeah, I normally just count it. I guess if you type it in, would it convert it for you? Maybe the newer calculators do. I just count it though, because obviously I know it has to be 3 point. 2, 4, 6, and then I go, well, that's 1, 2, 3, 4, 5, 6, 7 times that I've moved my decimal place. So that's how I do it. Obviously, you can put it in your calculator. That's also fine. The other one is then the opposite direction. So we've got write 4.96 times 10 to the negative 3 as an ordinary number. Now, the one with negative powers is actually, I think, a little bit easier because you just chuck that many zeros in front. So, for example, it's going to be 3 zeros, 496, and obviously, therefore, your decimal place has to go there. And again, you could count it if you really wanted to. 1, 2, 3. You can see. There we go. Yeah. So that one's pretty nice. But as I said, I think you've already had standard form, so whether it would come up twice, I'm not entirely sure. So for part C, we've got Asma was asked to compare the following two numbers. So we've got A is 6.212 times 10 to the power of 8, and B is 4.73 times 10 to the power of 9. She says 6.212 is bigger than 4.73, so therefore A as a whole number is bigger than B as a whole number. Is Asma correct? Well, technically no, right? She's not correct. No, because we're looking actually at this. If you were to convert them to ordinary numbers, the second one would be bigger, wouldn't it? So you've got to say something about that. Obviously, they've got loads of possible answers, but I would say no. Something like 10 to the power of 9 is bigger than 10 to the power of 8, or something about the powers. There were loads of answers, actually. Let me show you what we've got as examples. What question was this? Set 7. I'll just show you the... Oh, going too far. I'll show you the examples here. Look, loads of acceptable answers. So obviously you have to say no, but this is one of the acceptable explanations. So B is bigger as the power of 10 is bigger. 10 to the power of 8 is smaller than 10 to the power of 9. So you can say the opposite of what I said. Because B has more digits. You could even say that. A is millions, but B is billions if you were to actually convert the numbers. If you subtract A from B, the answer is positive. I don't know why you would say that. It's obviously, I know it's mathematically true, but I feel like that's a bit complicated. But you could say that. You could obviously convert both of them into actual numbers and be like, well, therefore B is actually bigger. She did not take into account the standard form at all. When you find the ordinary number B is greater than A, any of that version is fine. Yeah, it's a lot of different ways. And if you've got something that sounds a little bit similar to this, then I would assume that that's fine. Okay, so no, and obviously to do with the fact that she hasn't considered the standard form. Question 8, we've got shapes, angles, that kind of thing. I think you did have a question in paper 1 that was along the lines of this. So again, whether it will be repeated, I don't know. Question 8, the diagram shows a regular pentagon and a parallelogram. So this is parallelogram. Work out the size of the angle marked X. You must show all your working. So I was thinking, right, well, we only know 117. We might as well start there. Because it's a parallelogram, what I was thinking is obviously I've only drawn 2 of them parallel, but obviously the other 2 are as well. But just to look at this, think about angles on parallel lines. That obviously relates to parallelograms because they're also parallel. We could use co-interior angles, couldn't we? The C-shape one. So that would tell me this angle here, and I know that co-interior angles add up to 180. Now, they haven't said to give a reason, but that's, just to explain it, that's the reason. So if you subtract that, you should get 63 degrees. So that's the first bit. Then I was thinking, well, what is this whole angle here? This whole thing, because that includes X. Well, that's where the pentagon comes into it. So our formula, which as I said, I think you had to use in paper 1, so is something along the lines of this. If we want to know one angle in a regular shape, regular polygon, this one's a pentagon specifically, we do n, which is this number of sides, right? So 5 minus 2, unless you already know how many sides are in a pentagon, then that's fine. How many angles are in a pentagon, but I don't know that off by heart, so that's what I'm working out. This would give me the total angles in any pentagon, but I just want to know one, and because it's regular, they're all the same. So if you do that, that gives you 108 degrees. So that whole pink angle is 108. And then, yeah, last thing, well, X is obviously just the difference, isn't it, between 108 and 63. So we just subtract 108 minus 63. And yep, as you said, 45 degrees. And that's a nice 4 marks. Again, didn't even have to write any reasons for that one. So yeah, nice one, that one, if you've got the formula. Question 9, we've got an enlargement. I think you also had one of these in paper 1, so the ones that, you know, you've already had, obviously less likely they'll come up. So we've got enlarged triangle A by scale factor 2.5 with centre 0, 1, which they've already marked for us. So what I tend to do, I know some people draw the lines. I personally don't really like drawing the lines. That's just me though, but you could obviously draw the lines if you want. What I do is I go, okay, always go from the centre to the shape. So I'm going to choose the first corner, which is obviously closest. Because not only does my shape get obviously 2.5 times bigger, it also goes 2.5 times further away. So it's not just the shape itself, it's the location of the shape. So what I do is I go, right, I know it's 2 squares, but technically you could either use 2 squares or you could just count it as 1, it's up to you. Currently, it's only 1 away from the centre. So this new corner, I just need to do 2.5 times 1, which is 2.5. So obviously that is then, the new corner is going to be here. So I do that with the first one, just to map out where the position is. It's going to be there. Then from there, I just work out the size of the shape, right? So I can see that from this point here up, again, I know it's 4 squares, but I'm just using the fact that it's 2 up, isn't it, in terms of coordinates? 2 up. 2 times 2.5 is 5 up. So starting here, I go 5 up. So 1, 2, 3, 4, 5. Now, you can count the literal squares if you want. That's also fine, but yeah, you should get up to 6. And then from that corner, let's say across is 1, so that's 2.5 across, so 1, 2.5 here. And then I could just map out, here's my ruler, my shape. So not only is it, you know, as you can see, 2.5 times bigger, but do you see it's also, that was a really bad line, it's also 2.5 times further away from the center. So that's how I do it. You might use the lines, that's also fine. Yeah, if you want to go study English, you can do that. If you feel like you're ready for English and you want to study maths, you can do that. It's up to you. Whatever you feel like. Okay, so question 10. Just get my next sheet of paper. Oh, we've got a really nice solving one here. I don't really know how this is question 10, to be fair. It's quite a nice one, I feel like. So we need to solve 9 plus x over 7 is equal to 11 minus x. So to solve it, obviously you can see the whole point, that's my straight line again, the whole point is to get x on its own on one side, isn't it? So I need to kind of rearrange everything. I obviously don't want a fraction, that's the first thing. Let me get rid of the fraction. So I'm just going to multiply by 7 because, you know, how equations work. If you want to move something to the other side, you just multiply. Obviously that then opens up the 9 plus x, but do multiply all of this, so that would be 77 minus 7x. You can write it in brackets and then expand it if you want, but I just kind of multiplied it directly. If you have a negative scale factor, would you reverse the direction? Yes, exactly. You obviously can see that this one was also not negative because they haven't given you, if this was negative, it would be like down here somewhere, wouldn't it? Which they've not given you space for. But yeah, not only in that case would it be 2.5 times the distance, it would be 2.5 times in the opposite direction. So see how I went right here? Technically I would go left, and then where it went up, technically I would go down, and you get the gist. Yeah, that's how I do it. But again, you can draw the lines if you prefer. I know some people like to draw the lines. Okay, so obviously at this point, the thing is I've got x's on both sides. I want to bring them together. I want to have obviously all my x's in one place. You can move them to either side. What I like to choose is the side that will make the x obviously positive, because that's what I need at the end. So I'm going to move the 7x, because that, in order to move it, I'd have to add it, wouldn't I? You don't have to write these brackets in, I'm just kind of over-explaining. I'd add the 7x. It doesn't matter, you could move the x to this side if you want, but then you'd get a negative x, which to me is just more annoying, but it's not wrong. So I would add 7x, so that gives me 8x, positive, and probably at the same time I would just minus the 9, because I'm going, right, if I'm moving the x's to the left, I'll move all the numbers to the right. So take away the 9, you get 68, and then lastly, we just divide by 8, which you can do on your calculator because it's not a whole number, but it is just 8.5. That was pretty scruffy, 8.5. So as long as you get x is 8.5 at the end, it doesn't matter if you do a different order to me, because normally algebraic, well, rearranging, you can normally do different orders, so as long as you get the same answer at the end. Why did I times by 7? Because you see here, this is divide by 7, isn't it? Fraction means divide by 7, and I wanted to kind of open up that numerator. When you're solving, you don't want to have fractions unless the answer is a fraction. You don't want to have fractions here because that means that all of this is kind of locked in, isn't it? So I was like, let me just get rid of that 7 as a denominator, but therefore it means obviously, because I divide by 7 to make it a fraction, I have to times by 7 to do the opposite. Cancels out this 7, but then all of this you have to also multiply by 7. Hopefully that explains why. And then I got do you see how I got an equation with no fractions? It was much easier to kind of work from there. Also because I didn't want to do 9 divided by 7 or x divided by 7 because it wouldn't be a whole number, so I was just avoiding that as well. So just move it across. Part B, we've got simplify 4 brackets y plus 3 cubed over y plus 3 squared. So it's only 1 mark, as you can see. Effectively, it crosses out this one, and then you're still left with 1 in the numerator, aren't you? Yes, exactly. You're left with 1. You can expand it as well if you want, but I didn't bother. I just left it like this. They'll accept it like this, or they'll accept it if you were to expand it. You'd get that. Either or is fine. I didn't bother expanding it because it was only 1 mark. So yeah, the denominator completely cancels. It takes away 2 of that power, which then obviously leaves you still with 1 of the brackets. So yeah, nice 1 mark. I've seen another question that was very similar to this as well, actually, so it's repeated itself a little bit. So we've got probability trees. I know you've had probability trees, or at least probability twice now. But I feel like, I don't know, it comes up all the time, doesn't it? So it could be repeated again. So the probability tree diagram shows the probabilities that Bisma will be late for work on 2 days next week. We've got Monday and Tuesday, so you've got late on Monday, late on Tuesday. They are different. They're all different probabilities, that's fine. So it is conditional probability. So calculate the probability that Bisma will be late on exactly one of the 2 days. So I like to highlight my options. I know that, I don't know if in the exam you can literally highlight, but if you can just identify it somehow, maybe you can use a squiggly line or something. So late on exactly one of the 2 days. So he could be late on Monday, but then he'd have to be on time on the next one. And then he could be then not late on Monday, but therefore he'd have to be late on Tuesday. So those are our 2 options, aren't they? So when we work with probability trees, we always multiply between the branches. So to work out the green, you would obviously do 0.07 multiplied by 0.98. And then to work out the blue, you would do 0.93 multiplied by 0.11. And then because we've technically got 2 answers, we've got an option here, an option here. Because they are options, obviously you can't do Monday and Tuesday twice. I mean, not the same Monday and Tuesday, it happens only once. So it's either going to be late Monday, not late Tuesday, or not late Monday, late Tuesday. When you say or, that's when you add, isn't it? So if you say and, you multiply, which is why between the branches it's multiply. But if it's an or situation, then you add. So that's going to be my calculation. You can obviously work out the individual probabilities if you want. I'm probably just going to chuck the whole thing into the calculator, to be honest. 0.07 multiplied by 0.98 plus 0.93. I think the other one was 11, wasn't it? 0.11. Yep. See all of that now. And then I just wrote all of those decimals. You could leave it as the fraction if you want. It doesn't really matter with probability what you leave it as. Either fraction, decimal, percentage. Normally I leave it as fraction. In this case, because they were using decimals, I'm just going to use the decimals, and I will just leave it exactly like that because it's not that many decimals to write down. So I won't round it. I'll just put 0.1709. That's what I would do. Yeah, you could choose, just checking the comments. Yeah, I mean, the thing with probability trees is it's always the same, like, especially if they've given it to you already drawn. It's always, as long as you figure out which branches satisfy the question, I guess that's the hardest bit. Beyond that, you just multiply, and if you've got multiple options, then you add them at the end. Like, it's always the same in that sense. It just depends which branches you need to highlight to use. I guess that depends on the question. So it's an interpretation of the question as well, isn't it? I guess that's the bit that's hard. You didn't know the bottom one flips. In paper 2, yeah. The bottom one flips. What do you mean, like in this? I'm not sure what you mean by the bottom one flips. You mean that it's the opposite of the top one in terms of what I've highlighted, or just because it has to only be one of the days he can be late. So he can be late Monday, therefore has to not be late on Tuesday. Or you could be late, you could be not late on Monday, and then you'd have to be late on Tuesday because it has to be an exact one. Oh, you mean of the actual question in the paper? I don't think I saw the numbers. I've got the paper, but let me see. 0.8. No, it didn't flip. Looking at the question, it was 0.85, 0.15, and then again 0.85, 0.15 on the original, you know, the one that you actually did the other day. It was just the same. Yeah. Just from looking at it. Because it was pass fail, wasn't it? That was the context. Pass fail, pass fail. And there was no, because it was Freya and Ria, there was two different people. It wasn't conditional probability. This is conditional because it depends on what happens on Monday as to what would happen on Tuesday. Whatever happens to Freya did not affect what happened to Ria, so it was exactly the same probability, just copied. Yeah. Just from looking at it, because it was like, this was Freya, I think it was 0.8, 0.2, and then this was Ria, 0.85, 0.15, but because whatever happens to Freya is not going to affect what happens to Ria, is it? If you think about it. And they haven't mentioned anything in the question, so that's how I would have filled it out. Yeah, it was the same. Because it was pass, fail, wasn't it? Whatever happens to Freya doesn't really matter to Ria, does it? Yeah. But yeah, so, and then exactly whatever the question was, you know, multiply between. If there's multiple options, you add them up, that kind of thing. So this one was 3 marks. Normally I feel like it's 2 or 3 marks. Yeah. Yeah, you just have to figure out, is it conditional or not, but normally the question's quite obvious. In that question, it just said, this is Freya, this is Ria. It didn't really say anything about both of them together. Do you know what I mean? It just said one or the other, so it was separate. Okay, question 12. The stem and leaf diagram shows information about the heights in centimetres of 23 sunflowers. On the grid, draw a box plot for this information. So obviously a box plot, you need to have 5 things. I know you've already got box plots before, but maybe just in case you have 7 leaf diagrams come up. Unlikely, but maybe just in case. 5 things we need for box plots. We need the smallest number, which is obviously, because this is in order, isn't it? 173. You need the largest number, which is 219. And then beyond that, we need the upper quartile, median, and the lower quartile. Now, you can go through and tick them all off if you want. Because there's 23, there's quite a few, I just prefer not to do that. So what I do is, when it's an odd number, I make it even, so I'll add 1. To find the median, which is the middle, half that. So that is the 12th sunflower. So then I would just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 197. The only reason why I don't cross it off, I mean, if you did it in pencil, it'd be fine because you could rub it out, is because then we need to go back and have a look at the other 2. So the lower quartile, that was half, wasn't it? The lower quartile would be 1/4. So it'd be the same thing divided by 4, or just half that one, right? Which is the 6th one. 1, 2, 3, 4, 5, 6, 188. Nope, that one. 188. And then the upper quartile is obviously either you can count 6 from the end, or you can obviously just times that by 3 because it's 3 of those, isn't it? 3/4. The 18th. It's up to you. It works either way. Count 6 backwards or count 18 forwards. I already know this one's 12, so 13, 14, 15, 16, 17, 18. So that one is 209. And you can see if I did it backwards, 1, 2, 3, 4, 5, 6, you get the same thing. So once you've got that, it's just drawing it basically, isn't it? That's kind of the easy bit. Be careful with the scale. This one's quite a nice scale, but sometimes they are a little bit harder. So 173. Hopefully yours will look nicer than mine will end up looking. 188. It doesn't matter how tall you make the box plot, by the way, as long as it looks like a box plot. 197, 209, and then 219. And obviously these three in the middle create the box. As I said, you'll line it up a lot better than I will. I'm just kind of doing it roughly. And then these two are just kind of tagged on the outside. So something along the lines of that. There we go. Yeah, just checking my numbers. Yeah, that's all fine. Don't worry if you're late. You can always watch the first bit that we've been through afterwards, or you can go back and watch it later. That's fine. Don't worry about it. Question 13, density. We've got liquid A and liquid B are mixed together in a ratio of 2 to 13 by volume to make liquid C. Liquid A has a density of 1.21 grams per centimetre cubed. Liquid B has a density of 1.02 grams per centimetre cubed. A cylindrical container is filled completely with liquid C. The cylinder has a radius of 3 centimetres and a height of 25. You don't have to draw it, but sometimes I like to sketch it. So we've got 25, and then here is 3. Work out the mass of the liquid in the container, so liquid C. So with density, again, I think you already got this one, so might not be that helpful, but density, mass, volume, that's our formula there, formula triangle. I just first worked out the volume of liquid C. I thought, well, might as well do that because we've got the information, isn't it? It's just a cylinder, so it's pi r squared times the height, so that's basically 9 pi times 25, isn't it? Which I think gives you 225 pi. I'm going to leave it in terms of pi. I know it's a decimal, but just so that I don't have to deal with the decimal until right at the end. I try not to round it before. I try not to round it before I get to the end, because otherwise you lose some of the decimals. So that's one thing. That would get you 1 mark anyway. And then I was thinking, right, okay, well, I could split the volume to A and B because I've got the ratio, haven't I? So I'm going to share out that ratio of this volume here. So for the volume of A is 2 out of 15, isn't it? That's 15 parts of the 225 pi, which gives you 30 pi. And the volume of B is therefore the other. Well, you could either work it out like this, or you could just subtract it if you want. That's fine as well. 13/15. So that's the other 195 pi. So we've got the volume for each. We know the density of each, don't we? We know the density of A. Whenever you know 2 out of the 3 things from a formula triangle, you might as well just work out the third. If you're not really sure how to do it, you might as well just work out. Do you see how if I've got volume of A and density of A, I could work out the mass of A and so on. Same for B. So let's work out the mass of both separately. So that would be density multiplied by volume. So the mass of A is 30 pi times by the 1.21. Hang on, let me just check the comments. If you got 71, that's pretty close. Do you think it was maybe a rounding error? Did you round anything too soon? Because that's pretty close, isn't it? 73. That's pretty close. You might have done the right method and then maybe just rounded it too soon. I don't know. Okay. So this gives me, well, let's get the calculator because that's going to be loads of decimals, isn't it? 30 pi times 1.21, that's 0.21, make sure you actually type it in, is this, or there's loads of decimals here. So I'm just going to write down 363 over 10 pi. Again, because we're not at the end yet, that's the only reason why I do that. But that would be in terms of grams. The mass of B, same thing, 195 pi multiplied by 1.02. Which gives me this answer here, or in decimals 624 grams. 1989 over 10. And then, because they've asked for the mass in the container, that's just the mass of C, isn't it? So that's both of them added. So just literally add them. That's why I kept them as pi, because I knew that at the end I was going to have to add them. So I've still got that answer there, so I'm just going to go straight away and press add. 363. You could also store all the numbers in your calculator if you wanted to do it that way instead, that's fine. Now, because this is the final answer, I will look at it just as a number, and they have said to 3 significant figures, so that would be 739. I would round up, yeah. Okay, that's 739 grams. Question 14. A group of people went to a restaurant. Each person chose one starter and one main course. So you can see we've got starter options, soup and prawns, main course options, lasagna and curry. I'm missing out a line there. The number of people who chose soup to the number of people who chose prawns is 2 to 3. And then it kind of goes into detail about, within the soup people, it was this for the main course. Within the prawns people, it was this for the main course. I'll read that in a minute, but let's just actually get a gist of what we're trying to work out. What fraction of the people chose curry out of all the people who chose curry? So there are obviously multiple different ways to do this. You could just use the ratios as they are if you wanted, but what I thought was I was thinking, well, let me just put a number to it. Let me choose that 100 again. So let's say that there are, I know there's not actually 100 people, but I'm just going to go with, let's say that there are 100 people in total, and then we'll just share that out. That's how I did it. You could choose any number really, but I think 100 is quite a good one to work. So let's do this ratio. Soup to prawns, obviously adding it up, you get 5. 100 is divisible by 5, so that's quite good. So that's 20 per part. So soup would be 40 people, wouldn't it? Or if you want to think of it as a percentage, 40%. And then, what was the other one? Prawns would be 3 times 20, which is 60 people. Then, if I read this, so of those who chose soup, so of the 40 people we have that chose soup, the number of people who chose lasagna to the number of people who chose curry, lasagna to curry, is 5 to 3. Now that adds up to 8, which is quite convenient because my 40 also is divisible by 8, because now the total is 40, isn't it, for the soup bit? So 40 divided by 8 is 5. So the people who chose curry from the soup, so curry and soup, is 5 times 3, 15. Then I just do the same for the last one. So of those who chose prawns, that was our 60 people, the number of people who chose lasagna to the number of people who chose curry is 1 to 5, which adds up to 6. Again, quite convenient that it does divide. So 60 divided by 6 is 10. 10 people per part. So curry and prawns would be 10 times 5, which is 50. So my last thing was then I said, right, well, how many people chose curry in total? That would be 50 plus the 15, which is 65. And then I need to make it into a fraction though. But remember that I said my total was 100. So I went with 65 over 100. It obviously does also simplify to 13 over 20. But they didn't say to simplify it, so it doesn't actually matter as long as you get a fraction. Let me just check the comments again. No, this is not a predicted paper. This is actually one that people did. This was a November paper though, so these were the people who would have done this were retaking their exam. Normally November is the people who retake. So yeah. I've got the questions from the paper. I probably could at the end of this, I could probably just like write it myself rather than literally copy and paste it, but Yeah, but I'll do it at the end when we finish this paper, all right? Can I use a probability tree for this question? Oh, I see what you mean. If you maybe like a frequency tree, you know, when you like, so that one would be soup and prawns, and then you could choose like a num like that. Do you mean like that? I guess it's more of a frequency tree. Yeah, I guess you could lay it out like that. Yeah, I don't see why. I hadn't thought of it, but I don't see why not. What question is this? Question 14. Let's see what options they've given. Yeah. Yeah, I guess you could do. They haven't mentioned it specifically, but yeah, I think that would work if that made sense to you. Oh, a probability tree? I don't know. Well, yeah, you could do a probability tree if you wanted, I guess. Get rid of that. Yeah, I guess you could lay it out like that if you wanted. I just hadn't thought to do that. Yeah, soup and prawns, you could make them into fractions and say soup is 2/5, prawns is 3/5. You could make then, what is it, lasagna and curry, 5/8, 3/8. Yeah, I guess you could do that. Yeah. And then I guess you would just do soup and curry and then prawns and curry. Let's see if that works. 2 divided by 5, 2/5 times 3/8, add 3/5 times 5/6. Yep, 13/20, that would work. That would be fine. My predicted paper is coming on Monday. But to be fair, the paper 2 might still be helpful because anything that didn't come up on your paper 2 that's still in my predicted paper 2 is therefore then probably going to be paper 3, isn't it? So you can always have a look at that. Right, question 15. Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So I think you had algebraic proof in paper 1 anyway, but I always split this into 3 things. First of all, what type of numbers? Any two consecutive even numbers, so algebraically an even number is 2n, because any multiple of 2 is even, isn't it? But they want a consecutive even number, so the next even number after would be 2n plus 2, because obviously 2n plus 1, that's then the odd number, isn't it, if you think about it? Even goes even, odd, even, so on. So they're my consecutive numbers. My consecutive even numbers. And then I go, well, what was actually the calculation? The sum of the squares. That means I need to square them both and add them. I'm still not worrying about what I'm proving until right at the end. So let's square those. So obviously, first one is 4n squared, but the second one would expand, wouldn't it? It's effectively double brackets. So make sure you do expand the brackets properly. So you get 4n squared plus 4n plus another 4n plus 4. Simplify all of that, I get 8n squared plus 8n plus 4. Okay, that would most likely give you 2 out of 3 marks anyway. And then when I get to this point, I now actually worry about what am I proving. It's always a multiple of 4. Normally proof, there's some kind of factorizing. So if I look at this and go, well, how can I prove it's a multiple of 4? Well, I could just factorize out 4. That's 2n plus 1. Because it doesn't matter what's in the brackets. I literally don't care what's in the brackets. If I then multiply by 4, it is by definition a multiple of 4, isn't it? So I'd go therefore multiple of 4. And it's always because n could represent any number. If I substitute in any number, it doesn't matter. If I then times it by 4, it's a multiple of 4. I just tend to write a little thing that whatever they've said here, I tend to just kind of put therefore. Yeah, not a whole sentence, no. I think it's kind of self-explanatory, isn't it, there for the markers. But yeah, I just write a little bit just to kind of go, therefore, this is why it's correct. What if it said a triangular sequence? I've not seen triangular sequences related to algebraic proof, to be fair. Yeah. Because I don't know how you'd algebraically write, because it's like 1, then it's 3, then it's 6, and those are triangular numbers, aren't they? Yeah. Yeah, I can check it at the end. I can check that question at the end. So question 16, y is inversely proportional to the square of x. We've obviously been given our matching pair. Find the negative value of x when y is 8/9. Don't worry about what they mean by this until the end. It will make sense at the end. Just kind of imagine that it's a normal question. So my normal formula for inverse proportion is k over x, but obviously they've said the square of x. So, you know, account for that as well. Then sub in your matching pair. That will give you, well, ideally in the correct order, that will tell you what k is. You can work out what k is. Because this is a calculator one, I just literally went ahead and went, yeah, I obviously need to do 8 multiplied by 2.5 squared, which is 50. So k is 50. I like to then rewrite the formula just so that I have it very clearly written here. So that's my formula. This would be probably 2 marks so far. Find the negative value of x when y is 8/9. So sub in 8/9, obviously to y. We just need to solve this for x. So I just cross multiply to get rid of the fractions. 50 times 9 is 450. And then you can see from there, divide by 8. 450 divided by 8. You can leave it as a fraction or a decimal, it doesn't really matter. And then obviously square root. Now this is where we are considering the negative value bit that they mentioned. So square root, that's not square root. Square root that. Obviously I get 7.5, but when we square root anything, technically, it could have been plus or minus 7.5. So that's why when they say find the negative value, I'm going to choose negative 7.5. So it's only relevant right at the end. But because when you square root, you get a negative answer as well, technically. And it just depends on the context if it's relevant or not. Okay, let me have a look. Just looking at the comments. Yeah. Yeah, the square root of negative, the negative square root of 56/20, 56.25 is fine, yeah. How would it not be a multiple of 4 if n was 1? If you multiply anything by 4, it's a multiple of 4. Just by literal definition. Yeah, even if all the angles in a quadrilateral are different, they still add up to 360, and you just have to know the other 3. Yeah. Yeah, if you only have 2 angles, you obviously couldn't find out the other one unless you found out, you know, the 3rd angle and then the 4th angle. And it depends what you had in the question. I haven't looked at it in much detail. Like, I've got the paper, but I haven't actually like read through the questions properly. Yeah, exactly. Just take out 4. Okay, right. Next question. Get 11. If you subbed in 4, if you subbed in 1, you'd get 20, which is a multiple of 4. I don't know where you got 11 from. Because 2 plus 2 plus 1 is 5. Times it by 4 is a multiple of 4. Okay, question 17. Here is the graph of y equals x squared minus 3. Now, this is very important that you check what they've actually said here. because then compare it to what's down here. So they've said use the graph to find estimates for the solution of the equation x squared minus 2x minus 2 equals 0. Can you see how that's a completely different quadratic? You must show how you get to your solutions. Yeah, exactly. This is a completely different quadratic, okay? So what you have to do is you're not going to draw this quadratic, right? They're not asking you to do that. It's effectively simultaneous equations, but they've kind of given you the halfway point. So you've got this graph here. So let me write it again. X squared minus 2x minus 2 equals 0. And I want to rearrange it to get back to, let's say on this side, having x squared minus 3, and then there will be something on the other side. So how do I go from this to this? Well, first of all, this one doesn't have any x's as in the middle term, does it? So I want to get rid of that 2x. So to get rid of it, again, it's just an equation, isn't it? So you do the opposite, add 2x to both sides. So then I'm left with x squared minus 2. That's a bit closer. But do you see how on the other side I now have a 2x? And then I want not just minus 2, I want minus 3. So how do I go from minus 2 to minus 3? I would have to subtract 1. But again, because it's an equation, you have to do that on both sides. So my left-hand side is the same now. My right-hand side, you see how this other bit of information has now appeared. I've got 2x minus 1. So think about simultaneous equations. You know when you've got them both equal to y, you just make them equal to each other. Do the opposite of that. Go, right, okay, well I know that one of my graphs is this one. Therefore my other one is this one. And because imagine if you went this direction, like that would be the normal direction to work out simultaneous equations, wouldn't it? If you had these two graphs originally, you'd go, right, make them equal to each other and then move everything to one side. We're just doing literally the opposite of this, aren't we? So they've already drawn this one, so I don't need to draw that one. What I do need to do is draw this one. Now, hopefully you can recognize that. That is a straight line, just linear, isn't it? Y equals mx plus c. So plot two coordinates. Normally I like to plot just the y-intercept, which is 0 minus 1, because that's the easiest one to pick up. So here, and then I'll pick, let's say, another value for x, maybe 2, and substitute that in. So y is 2 times 2 minus 1, so that's 3. So my other set of coordinates is 2, 3. You can choose any, obviously, as long as it's on the graph. So that'd be here, and then just get your ruler and join them up, obviously expand the line kind of the whole way through. So there, and then if I carry it on there, now I can see the solutions. So where they obviously cross. The other thing though is because, do you see how the equation they've asked us to solve has nothing to do with y, like they haven't got a y here. So in our solutions, we don't need to write down the y values, just the x ones, okay? Just the x ones. So somewhere about here and somewhere about here. Obviously they give you a very small range of answers because even though your line should be the same as everyone else's, the actual drawing of that line might be slightly different. So for this one, what does that look like? I think I put like minus 0.75. Normally to 1 decimal place is fine, but that one I felt like was halfway. And then this one I put 2.7. That's what I got. You might have got something slightly different. That's okay. I'll show you the range in a minute. So I put, okay, for my solution is negative 0.75 and 2.7. As I said, you don't need the y solutions because they haven't mentioned in the actual equation that they wanted the y ones. So the range was 2.6 to 2.8 or minus 0.6 to, minus 0.8. So anything between those two is fine. You might not get exactly the same as what I've got. Okay, let me just check the comments again. I think the circle, it starts off in the middle and then went down by, I can't remember what number it was, by a certain number. Yeah. Yeah, well, this question's fairly easy if you know what to do, but if you've never seen it before, I feel like it'd be quite hard to kind of know that you'd have to draw a straight line. Sometimes I think the question says, by drawing a straight line, solve the equation, and it gives you a bit of a clue. This one, it didn't. But you just had to pick up on the fact that if, that's what I was saying up here, if in the question, when they mention this is the graph that we've drawn, if that's different to the graph or the equation they want you to solve, then that's when you have to draw the line. If it's the same thing, then obviously you don't have to. I haven't looked at it specifically, but I can have a look after the end of this paper. Yeah, vector circle theorems haven't come up. I feel like surely that's got to come up at some point, isn't it? Yeah. Okay, so yeah, that was that question. Question 18, I feel like you can just look at this and know at least the rough topic that this is going to be, but again, you've already had sine and cosine as you mentioned in your previous paper, so I don't know if they'd bring it up again. Maybe not, but you just never know, do you? That's the problem. So we've got the diagram shows triangle ABC. They've obviously labelled AB, AC, and BC. D is the point on BC such that the angle DAC, so let's find that, that's this one, is equal to 2/5 of the size of the angle BCA. So if you want to, I would say that's X. This one is therefore 2/5 X, or some version of that, just so that I can remember it. Calculate the length of DC, so this one here. So obviously I don't have enough about the smaller triangle to just straight away work out DC. But then you look at the other triangle and you go, well, I also don't have anything really about that triangle. So actually what we need to do in this case is I have to look at the whole thing. So try and ignore this line in the middle. Look at the triangle ABC as a whole. I've got all three sides of that triangle, haven't I? I've got all three sides, and technically it'd be helpful if I could find out this angle, which is an angle in the whole triangle. So if I've got one angle, three sides, that's cosine rule. The only thing is it's cosine rule trying to find the angle, isn't it? So that would be our subject. Now, whether you've memorized the rearranged version or whether you just take the formula sheet and rearrange it yourself, that's fine, but this is the rearranged version. Yeah, well, I'll go with A for now, because that's what's on the formula sheet, isn't it? Is b squared plus c squared minus a squared over 2bc. Obviously, then you do cos inverse as well. So in this case, you still see that? Just about. The angle we want is BCA. So if you need to, you can always change it and go, right, let me call that A, for example, and change them. It's up to you. Depends how confident you feel with, as long as you sub in, the correct numbers. B and C are always the sides that surround that angle. So I'm just going to go with like 2.6. That's a 6.2, not 2.6. 6.2 and 6.1, doesn't really matter which order those go in. As long as the 3.4 is the one you're subtracting. And then obviously 2 times the same, 6.2, 6.1. But as I said, if you need to relabel the angles, that's also fine. Now, I will type that into my calculator, but I'm also going to do cos inverse at the same time because I don't need to be writing down just a load of decimals, do I? So cos inverse because we're finding an angle, and then you just type all of this in. 6.1 squared minus 3.4 squared, 2 times 6.2 times 6.1, and you get 32.08 ... 32.08 degrees. Now I think that one for this case, because there was quite a few steps, I decided to store this. So I press Shift, STO, and then I choose one of these letters, so I just chose A. So now it's going to store that in A, so I can come back to it later. So this one is around 32, isn't it? We're obviously going to keep the decimals, 32.1 maybe. You could then obviously work out the other one, because I know that that is 2/5 of the size, isn't it? So I could multiply that one by 2/5. So that was DAC, wasn't it? Is 2/5 the size of 32.08. And it still is my answer, so I'm just going to multiply my answer by, well, 2/5 is 0.4. So that's 12.83 ... degrees. Again, I might store this one. It's up to you, you don't have to do this, but I just like to keep as many decimals as I can. So that's in B. Okay, let's have a look at our picture again then. So this one was about 12.8, wasn't it? So now looking at the smaller triangle, I want to find DC. I've got one side, I want to find another side, so that's two sides. I've got two angles, so I'm thinking, yeah, probably sine rule, especially because I've already used cosine rule. It's probably going to be sine rule. However, what I need is, yeah, the one I want is opposite the 12, so that's fine. That's a pair, isn't it? But the other side that I do have, 6.2, is opposite an angle that I currently don't have. Now, this is actually less complicated than it might look. If you've already got two angles in a triangle, you can work out the third one just by doing 180 minus. So that's all I'm going to do. 180 minus the other two. Again, this is why I kept the numbers saved in my calculator, because I knew I was going to have to use them again. So 180 minus, now because I saved it in A and B, didn't I? So A minus also B. I get 135.087. That one is ADC. So this top angle here. So let me just draw that. About 135. So do you see how now we can use sine rule? I've got the 6.2 opposite 135, and the side that I want, DC, is opposite 12.8. So let me move this across and I'll just do it next to it. Put it there. So sine rule, because we're looking for a side, we put the sides at the top, opposite the angle. So that would be the 12.8. Again, I'm going to have to use that 12.8, so that's why I've kept it saved in my calculator. Over, it's meant to be a 6. 6.2, and then the sine of that angle, 135, which is still in my answer. Obviously, then you have to times across, don't you? You have to multiply across. So my actual calculation will be 6.2 over sine 135 multiplied by sine 12.8. But I'll keep all of the decimals where I can. You see, I've still got 135 here, so I'm going to use my answer for that. 6.2 over sine of my answer, and then multiplied by sine of 12.8, which for me I saved it as B. You kind of have to remember which one you've saved it as. I guess that's the only problem. And then I get 1.95. They've also said to 3 significant figures, haven't they? So that would just be 1.95. Right, let me check the comments. Coefficient is the number in front of any letter. Depends on the context. I also have a video on the comparing coefficients thing if you want to look at that one. Or if you find another one, that's also fine. Yeah, you have to make the simultaneous equations, exactly. I think it's still quite complicated even when you've looked through it, to be honest, but yeah, you can have a look. Okay, just seeing if there's any questions for this one. No, doesn't look like it. All right. Question 19. Work out an estimate of the speed in meters per second of the cyclist at time at 6 seconds. So this is our tangent one, which again, you've already had, so probably won't get this one again. What I tend to do is, because we're trying to find the gradient of a straight line, is I tend to choose the actual exact coordinate. Before I draw my tangent, I'll look at the exact coordinate that they've mentioned, because then at least I know, doesn't matter really how bad my tangent is, at least I know one of the sets of coordinates is going to be exact. So that I read off as about 6, and then I did about, I was being kind of fussy, but I did like 10.25, because just be careful of that scale. Do you see the scale on this one? That would be like 12.5. So I think each 2 squares is 1, isn't it? So that'd be 11, 12, 12.5, so on. So I just did that. You could do 10.5 if you want. And then I drew my tangent. Let's see. I'm going to move this around a bit. Something about that. And then I think the other one I chose, just trying to find along that line another pretty decent one to read off. Maybe this one here. I think I went with 4. 4, and then this is 2.5. That's 3.5. So again, be careful of that scale on the y-axis. So then obviously it's just the gradient change in y over the change in x. Divided by the change in x is 2, isn't it? So 3.375. I just gave it as that. That's what I did. Obviously there is a range of answers, so let me just get those out. The range, the official answer they put was 3.4, so it was pretty close. But the range of answers, as long as you've got somewhere between 3.05 to 3.7, then they're happy with that. Because obviously your tangent will look different to everyone else's anyway, isn't it? 3 marks, but yeah, for those of you who might be in year 10, there's that one. Obviously, those of you who did it in paper 1, I feel like the chances of it coming up a second time is very, very low. Question 20, right, this is something that hasn't come up yet, so could be in the running for paper 3. Here are the first 5 terms of a sequence. We've got -1, 0, 3, 8, and 15. Find an expression in terms of n for the nth term of this sequence. They haven't mentioned that it's a quadratic sequence, but I feel like there's kind of 2 clues. 1, it's question 20, we're kind of towards the end now. And 2, the difference between them is not the same every time. So you think, yeah, this is obviously a quadratic sequence. If it was a different type of sequence, they'd probably mention it, right? If it was something completely different, but they haven't. So the method that I use is I just find the first difference, which is 1, 3, 5, 7. And then I find the second difference, so the difference between this row, 2, 2, 2. That should always be the same. There are people who do it differently to me. That's fine. You can do it differently. I'll just show you my method. This number here, the second difference, you just memorize this, is always equal to 2a. So then you can solve to find a. A is 1. Then, jumping up, highlighter again. So I'm working on this left-hand side, basically. Jumping backwards, this term, which is the first term, I guess, in the row of first differences, is always 3a plus b, which equals 1. Now, because I know what a is, that's why I have to do it in this order. Because I know what a is, I can work out what b is. So 3 times 1 plus b is 1. You can obviously just solve that as a linear equation. So you can see b is actually -2. And then finally, jump up again on that left-hand side. We're now looking at the first term in the actual sequence. And that one is the equivalent of a plus b plus c. So you know a is 1, b is -2. We can work out c. We've got -1 plus c is equal to -1. So c is obviously 0. That just means that there isn't a c value, which is fine. And then the a, b, and c are representing by a n squared plus b n plus c. So in this case, it would be n squared minus 2n. There wouldn't be anything at the end because obviously c is 0. So yeah. So yeah, hopefully that comes up in paper 3 because I think that's quite straightforward. If you've got your own method to work it out, then it's pretty straightforward. Okay, question 21. When a biased coin is thrown 4 times, the probability of getting 4 heads is 16 over 81. Work out the probability of getting 4 tails when the coin is thrown 4 times. So it's a biased coin, it's thrown 4 times. The other thing to know about this is recognizing the numbers. I know 16 and 81 are square numbers, but they're also certain numbers to the power of 4 as well, which is more relevant to this, isn't it? Imagine you've got your probability tree. You don't have to draw this, but just to show you kind of why this makes sense. It's basically like writing this, isn't it? And remember, we just said about probability trees, you always multiply between the branches. So what they've done is they've taken the probability of heads once and they multiplied it by itself 4 times. So that's why I was saying it's quite handy to recognize that these are certain numbers to the power of 4. So I'm going to do the 4th root of 16 over 81, which you might know, or you can obviously use your calculator to find it. 16 over 81 gives you 2 over 3, 2/3. So that's what we're saying. The probability of getting heads just once is that. Now, it's a coin. You can only get heads or tails. So the probability of getting tails just once is obviously 1 minus that answer. So that's 1/3. But they've said the probability of getting tails 4 times, so that's the same thing we just said. It's then 1/3 to the power of 4, isn't it? So that's 1/81. Yep. Okay, 2 marks for that one. 22, we've got some algebraic fractions. I feel like you haven't really had a big algebraic fractions question yet. So yeah, maybe something like this could come up in paper 3. So show that 7x minus 14 over x squared plus 4x minus 12 divided by x minus 6 over x cubed minus 36x simplifies to ax, where a is an integer. So there are different kind of orders to do these. I tend to like to try and simplify first if I can, and when I say simplify, it's factorizing. So I would probably look at that and just factorize everything I could first, just to see if it would simplify. So the first one, single brackets, I can take out, nope, I can take out 7 and I get x minus 2. Denominator is a full quadratic, so I know that will be double brackets. X and x, it's multiplying to make a negative, so I know 1 is plus, 1 is minus. Factors of 12 that add up to 4, 6, and 2. Now that's good because, can you see, I can just immediately cancel those out even before I start dividing. Divide by, obviously x minus 6 doesn't change, but this denominator is a cubic one. Now they won't make you factorize into triple brackets, but what they could do is make you pull out an x and then factorize into double brackets, because if I pull out x, you see how I'm left with x squared minus 36, which you should be able to recognize is the difference of 2 squares. X plus 6, x minus 6, again, pretty convenient. And cross out this. Now, the only thing is, when you cross this out, don't think that this is 0. There's still a 1 here, right? There's still a numerator there. It doesn't just disappear, okay? It's still effectively a numerator. So I've got this. Now, I'm going to divide, so keep flip change. So keep the first one, which is just 7 over x plus 6, change that, and then flip the other one, which I know would technically not have a denominator, as in it would be 1, but just so that you can see how to multiply it. Let me just get back to your question in a sec. Multiply 7x, x plus 6 over x plus 6. You can see what's going to happen. Cancel that, cancel that. They've said it would end up being ax. As you can see, we've got that, haven't we? We've got 7x. So I thought that was quite a nice one, even though it was almost the end of the paper. 7x, and that is 4 marks. Let me just have a look at your question. If the sequence was x plus 1, and more like this, would you have to work out x? I don't know. Are you referring to the quadratic sequence? What are you referring to? Yeah, just give me a bit more detail so I can kind of figure out what you're asking about. Okay, we have, look, I missed one. Oh no, 2 more questions. I think we've been through this one before. I feel like I've gone through this a few times, but obviously for those of you that haven't seen it, and again, I don't think you've had any cones or any spheres or hemispheres yet, so I feel like maybe that could also come up in paper 3. We've got question 23. The diagram shows a sector OACB of a circle with centre O. The point C is the midpoint of the arc AB, as you can see on this first diagram here. The diagram also shows a hollow cone with vertex O. The cone is formed by joining OA and OB. So it's exactly the same. Like, imagine you had this piece of paper here. They've taken the exact same one. I know it doesn't look like it's to scale, but they've taken the same piece of paper. They've kind of glued the 2 radius edges together, and it's created a cone. So that's why they've labeled it A, B, C, and A, and O, and all of this. It's the same thing. It's the same kind of piece of paper, if you imagine it that way. They then said the cone has a volume of 56.8 centimeters cubed and a height of 3.6. Height is obviously, that was horrible. Let me get an actual straight line. Yeah, that's a bit better, isn't it? The height is 3.6. That's the vertical height, the perpendicular height, not the slanted length side. Calculate the angle AOB, so this one, of the sector. Okay. Now, if this one you have kind of no idea where to start, it's basically you might as well start with the formulas they've given you, isn't it? Because why else would they give you these formulas? They've given us the volume of the cone first, and we know the volume of the cone, actually. So that's where I would probably start. So I go 1/3 pi. I don't know the radius of the cone. Do I? I don't technically know the radius. So I'm going to leave that as r squared. And then I do know the height is 3.6. And I do know that the answer to that is 56.8. So even there, you might as well just work out the radius of the cone. Even if you don't know why that's relevant, you might as well just work that out, mightn't you? So 56.8, you can do it in multiple steps. I'm just going to divide it all in one just to save some time. So that I would divide by 1/3. If I can type 1/3, that'd be great. 1/3, yeah. And I also want to divide by pi, move that across. And I also want to divide by the height, which is 3.6. So I just did it all in one step, basically, because this is quite a long question. So I've got this. This is the radius squared, isn't it? 15.0666 ... And then obviously you want to square root that, so you just want to know the radius. 3.88 ... Okay, so that's the radius of the cone. It's not the radius of the actual sector, right? It's not the radius of that one, just of the cone. Now, in this question, because there's quite a few steps, I'm going to, again, use my storage function. I'm going to shift store it in A. So that one is, you can always write it on your paper if you want to remember which one you saved it under. So that's that. Okay, I've used this. Then I'm thinking, well, they've given me another formula. I have the radius now, but I don't have this L, do I, the length? So that's then maybe the next thing I could work out, because if I draw a line here, I know it's a 3D cone, but just think of this as like a 2-dimensional right-angled triangle. And I know the height is 3.6. So do you see how I could just use Pythagoras to find the value of L, which is the same as OA or OB, whatever you want to call it. So that's Pythagoras. So 3.88 squared plus 3.6 squared. So I've got my answer here. For now, I can just use the answer, but later on I can use the letter A. 3.6, not 3.5 squared, and obviously the square root of that. So OA, or L in that case, is 5.294, which again, I think I'm going to store that. Hang on, store B. So 5.294, which is in B. Now, that's this side here, but it's also, if I've just said OA, it's also the radius of the actual sector, isn't it? So we've also got that at the same time. So we're getting closer. Now I can use this to find the curved surface area, because again, why have they given me the formula unless they want me to work out the curved surface area? So pi times the radius, now obviously the radius of the cone, right? Not of the sector, times by the slanted length, which is 5.294. So pi times, now I'm bringing back A again, aren't I? I want to have the whole of those decimals. You can write B or you can write the answer because it is the previous answer. So my surface area of the cone is 64.557. ... obviously. Now just think about that. We said originally you've got a flat piece of paper that is a sector, and then imagine you glue together these sides. Obviously just imagine there's no overlap. You've got a cone, so the curved surface area of the cone must be the area of the sector. That's how the two of them link. So if I come back here, area of a sector is pi r squared times the angle over 360. And I want to know the angle. I know the radius, I know the answer to the area. So now this is my last bit. If the area is 64.557, obviously I'll use all my decimals from my calculator, equals pi times the radius squared, which is 5.294 squared, times by the angle over 360. All I need to do now is rearrange this. Again, you can do it in multiple steps, you can do it in one step. I'm just going to take this, divide it by pi times, now this is where I'm going to use b because that was the 5.294, wasn't it? B squared. There, I'll do it in 2 steps, which gives me this, and then I need to times it by 360. So the angle is 263.95. Now, they have said obviously 3 significant figures, so 264 would be my actual final answer. Let me just have a look at the comments. Yeah. Work out the value of x. I feel like I'd need the whole question to be able to answer that one, to be fair. I guess obviously work out the value of x, you need to find an equation, I would assume. But yeah, I would have to see the whole question to see all of the details that they've given. Yeah. So as you can see, that was obviously a 5-mark question. They did give you more space, I just wrote it on the same page. Now let's just do our final question. This is vectors. It's actually not as bad as you think, this vectors question, you know. Even though it's the final question on the paper, it is 5 marks, but I don't know, it's not as bad as the normal ones. The ones where you were mentioning about comparing coefficients and making simultaneous equations. It sets itself up like that. It seems like it's that question, but actually we have so much information that we don't even need to do simultaneous equations. So it's like an easier version of that. So I don't know why it's 5 marks to be fair, but we'll take it. So we've obviously got a parallelogram, right, which is important to know. O to x is A, and then O to y, where's that? Oh, the diagonal one is B. Here's the point on OX such that OP, PX is 1 to 2. I'm writing 1 to 2, that's not the vector, that's just a scale, right? And then R is the point on OY such that OR to RY is 1 to 3. 1 to 3 again, not a scale, not vector, sorry, just vectors. This question is 5 marks. 5 marks. So work out in its simplest form the ratio ZP to ZR. This is, I feel like, where I would normally think, oh yeah, I need to find 2 vectors from the line that crosses through that one, which might be ORY, that line, and then compare them. But then I was like, but I know the vectors for ORY. So I was like, wait, hang on, that doesn't make sense. And the same thing here, I know the vectors for this one. So it is kind of different. So what I actually thought to do was just find ZR and ZP literally, because I have enough information to do that. And then at the end, we'll compare them. So the first thing that would be helpful is to know OZ. That's even just what I'd recommend with vectors questions. If you're not sure what to do, just start writing down any vectors that you can figure out, because normally the first 2 marks is just random vectors. So even if you don't know where you're supposed to go with that, just start labeling different vectors, because I think that's fairly easy to figure out. Because it's a parallelogram, if this one down here is A, then this one up here is also A. So think about it, if I want to go from O to Z, I would have to go B minus A. I'm going the wrong way. B minus A or A minus A plus B, whichever one you want to write. That's obviously the same also technically for this one over here, isn't it? So B minus A, because that's parallelogram, so it's parallel. Okay, so Z to P, just as a whole, would be the negative of that, wouldn't it? Because I'm going the wrong direction. Plus, and then I would have to share out this ratio. So that's 1/3 to 2/3, but I'm looking at the side OP, which is 1/3, so 1/3 A. Obviously expand, simplify, I get A plus 1/3 A, so that's 4/3 A minus B. Now, compare it to the other one, which was ZR. ZR. So again, I'm still going to come at the wrong way down the line OZ. But then I'm going to go up to R. So again, now just share out the second ratio, 1/4, 3/4. Obviously, I'm focusing on the side that is 1/4. So plus 1/4 B in that case. Now, scroll down. Obviously, expand and simplify that. So I would get A minus 1B plus it's minus 3/4 B. Okay, now I can compare, because I know that Z, R and P are all on a straight line. Because they're all on a straight line, it means they're parallel, which means one is a multiple of the other. So the scale factor, this is where you can compare the coefficients. We're not creating simultaneous equations as such, but you can compare the coefficients. Including that. So it doesn't matter, I guess, which way around. I was thinking to go from the smaller to the bigger, because that's just a 1, isn't it? 1 to 4/3. Obviously, the scale factor between it is 4/3, which should be technically the same. You can always check if you want to, but because I know it's on a straight line, then I know it's the same. Like if I had, I know they're both negative, but just for now, 3/4 times it by that scale factor, which is 4/3, you can kind of see where this is going. is 1, isn't it? So that matches for B. The scale factor is 4/3. Now that's 4/3. ZP is the bigger one, isn't it? So I just looked at that and went, yeah, that's 4:3. Because the ratio is the whole line on one side, and on the other side is the smaller part of the line. So it's just the 4 and the 3 like that, isn't it? That's how I did it. Again, there's probably loads of different ways to do it, but that's effectively how I did it. So it seems like the one where you have to compare the coefficients, but it is, but you don't have to make simultaneous equations, because we had enough information to not have a K or some kind of letter or some kind of scale that was missing, wasn't it? We had enough there. So a bit of a trick question, that one, I feel like, because it was the final question on the paper, but it wasn't as hard as the normal vectors ones, I feel like. Yeah, let me have a look. Yeah. Yeah, ZY is A as well because it's a parallelogram. The graph question, I can have a look at the graph question now if you want. Is it 1 mark to write down just A? I don't know. Let's see. Probably not. You just quickly check the mark scheme and then we can go through. The first mark is for process to find a missing vector using given ratios. So OX or OY. Where's that? Oh, I guess that was my 1/3 A or 1/4 B. That's one mark. Another mark is for process to find OZ or ZO, or this side here, XY. That's all the same. So that's the second mark. So no, you wouldn't get a mark for just writing A up here, if that makes sense. That wouldn't be enough for a mark. The third mark is for process to find either ZP or ZR. So the first bit here, that's my third mark. The fourth mark is for process to write ZP and ZR as multiples of the same vector. So that was me writing my scale factor. Scale factor is 4/3. And then obviously the final mark is for your ratio. The scale factor is 4/3 because, do you see the bits I've highlighted? To go from 1 to 4/3, you multiply by 4/3. To go from 3/4 to 1, technically that's a 1, isn't it? You also multiply by 4/3. So the scale factor, I was looking at it from the small one to the big one. That's the direction I was looking at. If you were to look at it from the big one to the small one, it would obviously be 3/4 as a scale factor. But I went from small to big, just because in my head that makes more sense. Let me have a look at that on my... By the graph question, do you mean there was one that was an exponential graph, like the one that was going down? Oh no, there's also... Well, no, that's an inequalities one. Do you mean the circle graph question? Which graph question? Just let me know. Oh, there was also one which has got straight lines. There's actually quite a few graphs here. One with straight lines as well. Let me know which was the graph question you want to look at. I could do a little sketch. Anyone for the graph question that was on your paper 2? Just let me know which one it was. We can have a quick look at it. If not, then I think you said you wanted to send me a question that you had specifically. If you want to do that, let me know now. Nope, no one. Show y is greater or less than 4. Hang on. Let me see which one that one was. Not the circle one, is it? Oh, the one with the straight lines. That was a 5-mark one. What was the question? Was that question 20? Yeah. Okay, let me have a quick look. I haven't actually been through it, so let me have a quick look. I'll just draw a little rough sketch. So, use the arrows for the axes. So that's y, x. Then I'll get some straight lines. So you've got one line that goes kind of diagonally down like that. And then one that goes up. bit steeper, that one. Something like that. This one they've mentioned is L. This is point A, point D. Obviously that's O and then B. Okay, let me read it. On the diagram, point A is 0. Oh, that's 8. 0, 8. Let me rub that out. 8 for A. And B is 16. Fine. B. The line D. Oh, the line D? Oh no, the point D divides the line segment AB in the ratio of 1 to 3 parts. Okay, so this is like a 1 and this is like a 3 scale. The line L passes through D, as you can see. The gradient of L, okay, is root 3. L passes through the coordinates with minus 2f. So like minus 2, somewhere down here, I guess. Let's call that f. Show that f is less than minus 4. It basically says, that question is find out what f is, and then hopefully your answer will be less than minus 4. Okay, let's have a look. Let me get the comments back. Let's see, let me think about it. So we want to find the coordinates of this one. So in order to, I'm kind of backtracking in my mind. Because I know that that's minus 2 something, I've got one of the coordinates. So what I want to know is, I guess, the equation of this line, because then I could just sub in the minus 2. I've already got the gradient. I need to know it's obviously minus something, isn't it? The plus c is obviously a negative. I need to know what that is. Okay. I don't have any full coordinates that are on this line so far, but that's what I'm thinking, right, okay, maybe point D I could work out, because obviously I have to use the ratio, right? Otherwise why have they given that to me? It's not the midpoint of AB, but it's kind of, I guess, similar logic. So I could go, right, this is obviously 1/4 of the line, this is 3/4 of the line, isn't it, if we put it into fractions? So in terms of, we've got 2 sets of coordinates, haven't we? We've got 0, 8, and we've got 16, 0, or 16, 0. So I know vertically that's 8 and horizontally that's 16. So I could work out the coordinates of D. That's probably where I maybe start, and then from there just sub it all in. So let's work out the coordinates of D. If that's a quarter, I know it's diagonal, but I'm just going to work with it being obviously a quarter down and a quarter across. Yeah, because the midpoint would be half down, half across, wouldn't it? So a quarter of 8, I think they've chosen that deliberately, 8 and 16. There's multiples of 4, aren't they? 8 divided by 4 is 2, but obviously that's then 2 down, isn't it? Minus 2. So therefore D would be, what, 6? And then it's a quarter across, so 16 divided by 4 is 4. So 4 across. Now that does start from 0, doesn't it? So that's fine. So is that 6, 4? No, I've done it wrong around. 4, 6. 4, 6? I don't know if that's right. That would be my guess. Yeah, 4, 6. Yeah. Okay, so we work out the coordinates of D. I think that's probably the hardest bit. From there, it's just straight line graph stuff. So this is the line L, isn't it? So to find the equation of line L, you have to obviously substitute in coordinates that are on that line. So line L would be 6 is root 3 times 4 plus c. So let's divide that. 6 divided by 4 root 3, basically, isn't it? 4 root 3 gives it to me as 3 root 2. Root 3 over 2 even. Why did I say 3 root 2? Is c. So my equation for line L, the full equation, is y is equal to root 3x plus root 3 over 2. Okay. Does that make sense? No, why have I divided it? I was thinking it needs to be negative. Let me redo that. Ignore me. We need to take it away. Why was I? Yeah. Okay. 6 minus, because it needs to be a negative number, because you can see on the graph it's negative. There we go. That's better. Oh yeah, it's loads of decimals. Okay, that's not very helpful. So just 6 minus 4 root 3, which is a negative answer. So I know it says plus 6 minus 4 root 3, but that is a negative number. As you can see, negative 0.928 dot dot dot. So that's the equation of line L. What was I working out? I was working out what f was. Okay, once I've got the whole equation of line L, it's over a bit. If I just sub in -2 for x, then it will give me what f is. So y is equal to root 3 times -2 plus 6 minus 4 root 3. So I can just add that together. So I've got my answer here. That's still the 6 minus 4 root 3. So I've got basically -2 root 3, isn't it? That's a plus my answer. And that gives me 6 minus 6 root 3. But because they wanted us to show it was less than 4, I can now convert it to a decimal. Do you see how that's just minus 4.39? Which is less than -4, isn't it? Because it's a negative, it is less. Yeah, so that's probably what I would do. I think the hardest bit was the first bit, because it's kind of the same logic as working out a midpoint, but you've not got a midpoint, you've got 1/4 and 3/4. Once you've got that, then it's I guess confusing because it's surds and not just straight numbers, but it is, you know, normal steps for just anything you know about straight line graphs. Okay, when am I running my next live? I'm thinking to do the next live Saturday, maybe earlier. I don't know if you would you want 5 o'clock on Saturday, 4 o'clock on Saturday, and then it would be, I'd have to check which one it will be because we're going backwards. If you want to see the more recent past papers, then we've already been through those, so have a look in my lives playlist. We did obviously paper 2 before. What did we do before then? June, November 20. I think it would probably be June 2019 paper 2. June 2019 paper 2 would be the next one. I'm still doing paper 2 and paper 3 because, as we've said before like a million times, the topics aren't really split that obviously, so don't just sack off paper 2 because you've already done it. It could still be topics from that, you know, a past paper 2 in your paper 3. So yeah, probably June 2019 paper 2, and then the next one will be then June 2019 paper 3, and so on. The quadrilateral one. Oh, the sine and cosine one, like at the end? Question 23 was the last question on the paper. I'm gonna have to try and draw this. Again, I've not really looked at these properly, so I'm just going to be trying to figure it out, basically, with you. It's quite big, actually, isn't it? It was something like that. That was D. This says 6. That was A. 125. This one we don't know. This is B. We know the whole of this is 12. 60, and then C. And then this is 9. What was the actual question? Hang on. So find the size of angle ABC. This one. Obviously to the nearest degree. Okay. I'd imagine there's different ways to do this one as well. I mean, the working that someone's written, they've like split it into like 3. They've split it into 3 triangles. How would I? Let me have a think about this because I've not looked at it properly yet. How would I do it? Just processing it for a second. Draw a line across there, then I could use cosine to work out that side. Then I could use cosine again to work out that angle. And then if the line was there, if I knew that side. Okay. I think I've got a plan. We'll see if it actually works out because I've not tried it out yet. My thought is to just split this here. The one that I've screenshotted, like someone who's uploaded it, they've split it into like they split it twice into 3 triangles, which feels more complicated to me than anything, but have I drawn it correctly? Yeah, right? I'm just sort of, because I've only seen their version where they've drawn on top of it, so I'm hoping that that's correct. I would probably split this up, I think. Let's test this out. And I think I would use cosine rule to find out dB, because why not? Might as well. As in cosine rule obviously from this bottom one here. So I've got 2 sides, the angle between them and the side I want. So dB squared would be 9 squared plus 12 squared minus 2 times 9 times 12 cos of the angle 60. Work that out. You can see all of that. I'm just going to write 81 and 144 because the squares are kind of annoying to type. Minus 2 times, no, that's not times 9 times 12 times cos 60. All right, and then square root that. Well, I guess you're 3 root 13. I'm not going to write the decimals, but it's about 10.8. But 3 root 13, let's write that as dB, just to keep it as a, you know, exact number for now, because it's obviously not the final answer. So I've got that. Then what I was thinking from there was still in this triangle. I've split this angle in two now, haven't I? I was thinking still in this triangle, I've now got three sides, and I want to know this angle. You could either use cosine rule, because you've got enough information now. You could either use cosine rule again to find out the angle, use the three sides, or you could use sine rule. Could we? Yeah. So you've got that one opposite there, that one opposite there. Yeah, let's use sine rule. So I could work out that portion, dBc. So because we're looking for the angle, obviously put that in the numerator, put that on top, over the opposite side, which is 9 sine of 60 is the opposite side, which was 3 root 13. Obviously, remember you have to rearrange that. So sine inverse, because I'm trying to find an angle, sine 60 over 3 root 13, which was my previous answer, wasn't it? So I'll just put that there, times by the 9, just kind of whizzing through it really quickly, 46.1, so that's dBc, 6.1, so that's this bit here, one, and then looking at this top triangle, again, I guess we could use sine rule, because I've got the side and angle, and then this side is opposite that angle. I think I would do that. I'm doubting myself because I've seen someone else do it completely differently. That's the only reason. So I don't know. We'll see if I get the same answer. So what are we looking for? We're looking for, again, sine of the angle ABD in this case over the opposite side 6 is equal to sine 125 over 3 root 13. And then again, you rearrange it the same way. So sine inverse of sine 125 over 3 root 13. It's no longer my answer, so I have to type it. Times 6, 27.02. Dot, 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 obviously. And then I guess you just add them together. This is where we find out if I'm right or not. Ah, yeah, 73. And they said to the nearest, hang on, let me check. Give your answer correct to the nearest degree, so yeah, 73. That's how I would do it. As I said, the one, like the person who uploaded it onto TikTok that I've kind of copied it from, they did it a different way and they still got 73. So you don't have to necessarily do it my way. As long as you get 73, I would imagine that's fine. Can you see all of that? Hang on. Yeah, just about to see all of that. Let me just check, hang on. Use sine, okay. Use cosine to get D. So you forget that cosine is only triangle. What do you mean only triangle? Use cosine to get D. Oh, like the whole, wait, what, you mean this? The whole of that? I don't know how you could have used cosine to do that then. Did you use 6, 9, and 12? Yeah, I don't think they could give you. Yeah, because obviously cosine rule and sine rule and any trig only relates to triangles. So, oh no. Ooh, I mean, obviously I don't have an actual literal mark scheme, right? It's just whatever people have written. But no, I mean, because that is technically mathematically wrong, like completely. Then yeah, I don't think. If you had wanted to find out D, you could have drawn a line. Like I've drawn it the other way, but you could have. Oh. Like your logic of the 360 minus is obviously correct mathematically, but you could have drawn a line here and then used, could you? Hang on, wait, you've got this side. No, because you don't even have that. You'd have to find that side to find that angle, wouldn't you? How do you find that side? You've got this. No, I don't think you could even do that, to be fair. I don't think D's even related. Yeah, yeah, I'm sorry. Yeah, probably best to remember that trig works only with triangles, I guess. Yeah, you just split them all up. But as I said, I did see them, I don't know why, but hang on, let me have a look at their picture. For some reason, they drew, like, the one that I've seen, they've split it like this. And then they've worked out, they put that as 9. I don't know why you would do that, to be fair. I probably wouldn't do that. But they've also got 73 somehow. So, yeah. I think that's probably the most direct way. Yeah, or it depends how well you did with the rest of the questions, because I think you can afford to lose the 5 marks if you've done, if you feel happy with how the rest of it went. I just don't know how you feel like the rest of it went. Yeah. All right, well, okay, guys, I think I'll leave it here. As I said, probably Saturday will be the next one. I'll schedule it so you can go on my channel and see when it's scheduled for. But that will be June 2019, paper 2, obviously higher. Might do on Sunday as well. Probably Saturday, Sunday, Monday. We'll do papers. My predicted paper will be released Monday morning as an actual video, so you can look at that. And I'll do a last minute kind of revision video that we'll upload on Tuesday night anyway. But yeah, best of luck with your English tomorrow, guys. And thanks for joining me anyway, and I'll see you Saturday then.